solve. We're going to take a look at now these logarithmic equations, and we're going to solve them. And we're just going to use that equivalent form we used for the evaluating. And that's what I mean when we actually see these equations in this form where I have a log equaling some number. Essentially what it comes down to after that is the exponential form in most cases to solve these. So remember, this is what it is. Y equals log base b of x, and that's equivalent to b to the y equals x. So now, because we're still getting used to this, I bring it up. So take a look at this equivalent form. So this would be the base, which is x. So it's going to be x to the other side, which is 2 equals 49. Okay, now what I can do next is I square root both sides. And then I would get x equals plus or minus 7. Now we have to be careful here because in the beginning, the few videos back, there were conditions for logs and exponentials. So take a look at this. Those conditions were where x is greater than 0, b is greater than 0, and b is not equal to 1. So remember that x is what I'm taking the log of, and b is that little number at the bottom there. So that's how we have to remember that. Remember, x has to be greater than 0. And we'll understand that a little more once we graph them. So what I'm getting at here is it can't be the minus. So actually my answer is x equals 7. And the reason why is because that x is 7, remember my base here had to be greater than 0 to begin with. So that's why the negative is not counted. That's my answer. All right, let's take a look at the next one now. Okay, so again, we're going to do exactly the same thing here. So I'm going to take this 1/4, that's my base, to the x. Oh, hang on. Remember I said mostly? Check this out. 1/16, I just caught this. Okay, now there's a few ways to look at this. Actually, no, this will still be the easiest way to do it. We can do it just using the log directly, but we're not going to. And you'll see why in a little bit. This gels a little later once we do a few more examples. So anyways, so we'll keep it this way. So I see here that my x here should equal 1/16 when I'm done. So I want to get these both in terms of the same base. So I can call this 1/4 to the x. That's what it is. Let me keep it right there. So then this here, I can also write as a 1/4 squared. Hopefully you've seen that. If you didn't, there it is. Hopefully you can see it after this. So that tells me my x equals 2. So there's my answer for that one. Now again, I turned it into its equivalent form. Let's try the third one now. Okay, so this is going to be 6, and this one's a lot more busy here. This is going to be 6, and that's this base down here, to the other side, which is 5x plus 3, and that's going to equal what I'm taking the log of, so it's 36. So now I want to get these both in terms of base 6 if I can. So that's 6 to the 5x plus 3, and that equals 6 squared. So what this tells me then is since those bases are the same, I can say 5x plus 3 equals 2. And again, you're not wiping them out or anything. You're not wiping these 6's out, so don't think that's what you're doing there. Essentially, this is just a comparison. If these are the same and they're going to be equal, then these exponents also have to be the same. And that's really the idea here. If you want to get your hands on that, we'll talk later on about a way to do that if that bugs you. So from here, we're going to subtract 3. So that's 5x equals -1, and I divide by 5, so x equals -1/5. So I have to ask the question, is that going to be legal for us? And hopefully you guys realize it is. And the reason why it's okay is because this x is not my base or what I'm taking the log of. So that's what makes it okay here. Okay, now if it was one of these pieces here, like where the 36 at or is where the 6 is, then I could say no solution. But Otherwise, in this state, I can't because it's actually just this expression on the other side is where my x is at. Okay, next problem. Okay, so this is going to be 3, which is this, to the other side, which is squared, equals whatever I'm taking the log of, which is x squared plus 1. And again, once you get those steps down, it's fast, and you can get through them really quick. It's just a different process because we're dealing with different mathematical objects. So 3 squared is 9. 9 equals x squared plus 1. So since I don't have an x in here, I just have an x squared, I can move the 1 over, and this would be x squared equals 8. And then I would square root both sides. Oops, I forgot my parenthesis there. And then this is going to be x equals plus or minus 2 square root of 2. And hopefully you're okay with that because 8 is really, let me put the plus or minus here too. Square root of 4 times the square root of 2. And that square root of 4 is 2. That's how we simplify radicals. Essentially, you're just trying to find any factors in it that are perfect squares. And those can actually square root. And that's what you do there. That's where it comes from. But anyways, that's our answer here, and we have to check to see if it's okay. So I'm going to plug it in, and I'm just going to use the square root of 8 there because I want you to see that. And I'm going to plug in the positive one. Okay, so log base 3 of square root of 8 squared plus 1. And all I'm going to work with is the left side here because on the right side I just have a constant. And remember, this has to equal 2 when I'm done. So the log base 3, and then 8, square root of 8 squared is 8. 8 plus 1 is 9. So that actually equals 2. Okay, now I'm going to try the negative. So log base 3 of negative square root of 8. Oops, let me put 2 there. Squared plus 1. And remember, when I'm squaring it, it makes it positive because I get a negative times negative is positive. So this gives me the log base 3 of 8 plus 1, which is still the log base 3 of 9, which equals 2. All right, so they both check. And because of that squaring that I have in this one, my x being negative is also fine and positive. So keep that in mind with these. Just because I have an x that's a negative doesn't mean I'm not going to count it. Remember, when I plug it in, that expression I end up with, once I plug in that variable, that value I get when I plug it in that expression in there, if it's positive or greater than, or I should say, yeah, it's positive, then I can use it. So that's how it works. So just remember that. Just because x is negative doesn't mean I can't use it. Very important point here. So this actually has 2 answers. Another thing this shows me is I have to check. If I don't check, I'm not going to know if it's correct or not. So on a test, that's what I'm going to want to see as well. And if one of them doesn't work, you can just put an X on it or something like that. But this one does, so you wouldn't. But just keep that in mind, that you will have to check for these because the way the logs work and when I turn that into exponential form, the reason why is because I have domain differences between logs and exponentials. So there we go.